All right, so today we're going to be graphing logarithmic equations here. So we have the equation right here of the stuff. It's just like we've been doing before of what each one of them does. So we have a vertical asymptote, so this time it's going up and down because it is the inverse function of an exponential. So if you graphed it, it should look like a reflection over the y equals x line. So you have an asymptote x equals 0 in its standard form. H still moves it left and right, opposite of what we see. K goes you up and down. This time we'll graph 2 points. So we're going to graph the x-intercept, and I don't know what that is supposed to stand for. But when we have this right here, we're going to have 1, 0 is always a term, and then B1. So 1, 0 is always a point that hits on it, and then B1. And then we're going to apply any transformations. This time our range is negative infinity to infinity because we've swapped the x's and the y's, and your range is going to be your k to infinity, or if you have to flip it, it's going to be negative infinity to k. So to graph some of these right here. So in standard forms, we have the points 1, 0, a half, 1. And I wanted to graph these up here. So if your b is greater than 1, then your graph will look like this, where you hit 1, 0, and then that's your B1. If your B is less than 1, so between 0 and 1, then your graph actually ends up looking like this instead. So you get still 1, 0, and then your B, though, is a smaller number, so it's up here. B1's up there. So this one right here, before we would have any movements, we'd have a half 1, and then B0. So it would have looked like this, but I need to move that graph up 4. Let me get my little blue pen. 1, 2, 3, 4. So 4 half. My graph looks like this. It will continue to go down forever and ever. So my asymptote is still at 0 because we did not move it left and right at all. And then my domain is the 0 to infinity, and your range is now at negative infinity to infinity. So this one starts off at 5, 1, 1, 0. Let me get my black. We're going to go left 2 and down 2 for our movements. So your graph without any movement would look like that. So I'm going to move both my dots left 2 and down 2. So 1, 2, 1, 2. 1, 2, 2. My new asymptote is over here at the negative 2 line. So there's my picture. This time x is equal to negative 2. My domain is negative 2 to infinity. The range is still negative infinity to infinity. So I'm going to get 1/3, 1, and 1, 0. Again, it's going to look like the other ones, and this one's going to move right 1. So originally, a third one would be like here and here. So it would look like that. I'm just going to move both of those right 1. So there's your picture. So x equals 1 is now my asymptote. My domain is 1 to infinity. My range is negative infinity to infinity. So the only difference when we have natural logs on the back, you guys, is that your b is always e. Always e. So we're going to have our point 1, 0, and then b1, which is your e. And this goes up 1. This one would be 1, 0, e1, and this one's going to go left 1. So before movement, we would have this dot and 2.7 about here. Move both those dots up 1. One, 0, E1. I can move those left 1 now. So this would be x equals 0. This is x equals -1. My domain here is 0 to infinity. Range is -infinity to infinity. Domain here is -1 to infinity. Range is -infinity to infinity.